Okay, so let's review. We're done with chapter 9. Let's review what we've done for chapter 9. We first define angles as rotations, and that allows to redefine degrees into the way we measure angles as degrees into radians. We then introduced the idea of the unit circle, and we put the ray on the unit circle, and we looked at the coordinates, and we saw that the coordinate had 2 points, a point above the x-axis and the distance from the y-axis. We call the distance above or below the x-axis the sine, so y sine, and we call the distance from the y-axis to the left or the right cosine, x cosine, cosine, sine. We also saw that the tangent ratio, we defined that as sine over cosine. The next thing we did was we broke up the coordinate plane into 4 quadrants. We went counterclockwise, first quadrant, second quadrant, third quadrant, fourth quadrant. What we were able to do is we were able to look at this point and see, because in the first quadrant, they're both positive, sine and cosine are both positive in the first. If we look at the second quadrant, only sine is above the x-axis. The y-coordinate is to the left, so sine is positive, cosine is negative, and therefore the tangent is negative. In the third quadrant, because sine and cosine are below and to the left, tangent is positive. And if we look at the fourth quadrant, if we look at this point in the fourth quadrant, sine is below, so sine is negative, but cosine is positive, and therefore tangent is positive. So these tell you which one is positive. All students take calculus, all sine, tangent, cosine. These are the ones that are positive. Okay, then we were able to look at the unit circle because we found from the special triangles, we were able to find the sine, cosine, and tangent of the quadrantals 0, 90, 180, 270, 360. And then we were able to find the values of sine, cosine, and tangent at 30, 45, and 60. We were interested in the rotations in the third, second, third, and fourth quadrant. So we talked about the idea of reference angles. So the quick way was how far away is the rotation from the x-axis? So like 150 is 30 away from the x-axis. So the reference angle for 150 is 30. How far away is 300 from the x-axis? Oh, well, it's 60 away. The reference angle for 300 is 60. Therefore, we were able to find the sine, cosine, and tangent for all the multiples of 30, 45, and 60. Now, with all the rotations and their corresponding values, we were able to make graphs. And so this was the sine graph, this was the cosine graph, and this was the tangent graph. Take note of the asymptotes here, that it was undefined at 90 and multiples of 90. Now, we saw that all these functions, they repeated, hence the idea of the periodic function. So we saw that sine and cosine have a period of 2 pi. They repeated every 2 pi, and the tangent function repeats every pi. It goes up, up, up. And we defined amplitude for sine and cosine. We defined amplitude. And for all three, we defined the period, which we just said. The period is 2 pi, and the tangent was pi. We found that the domain for the sine and cosine was all reals, and the range was from -1 to 1. And the domain for the tangent, well, the range for tangent is everything. There is no y value it doesn't cover, but it's not bounded. But the domain had a restriction. It could be anything except 90 degrees, and anything plus or minus a multiple of pi. So 90, 270 plus pi, anything. Or we could have gone backwards. Remember, these graphs go both ways. Okay, well, let's continue. So if we have an inverse function, if we have a function, we'd like to have an inverse function, right? And so if the function is y equals sine of theta, then the inverse function, we know it's the same idea. Let's call this x, because it's much easier. If we know this is x, we can say, okay, fine, x equals sine of y. And like logarithms, the inverse of exponents, we have a special, way to write this. So we don't write this, we write y equals sine of x to the -1, inverse sine, or we write y equals arc sine of x. And so, for example, if sine of pi over 4 equals radical 2 over 2, then the inverse sign of radical 2 over 2 equals pi over 4. Okay, and so the problem is, okay, what's the problem though? Is that when we look at our function, we know that the problem is that a function must be 1 to 1 to have an inverse. And we clearly can see that sine is not 1 to 1. It fails the horizontal line test. So we have to restrict the domain. So let's take a look at sine. We look at the sine graph. Up at this. We can go back the other way, actually. We're going to do that, actually. We're going to keep going. And the idea is we need the part of the graph that is we need the part of the graph that is only 1 to 1. What we're going to do is we're going to restrict the domain. So we're going to start at negative pi over 2 and go up here. So if, can you see me down there? We'll see how this plays out. So if the domain is from negative pi over 2 to pi over 2, and then the range is negative 1 to 1, then we can say that the inverse of sine of x, the domain is from negative 1 to 1, and the range now is from negative pi over 2 x inverse sine to pi over 2. And so what does that look like on the graph? Well, we know we can just switch the x and the y's. So we kind of know, let's say, what it looks like. It kind of looks something like this. So this is the inverse. That's the inverse function. That's y equals inverse sine of x. Now, what's the point of this? Well, once again, it's for like technology purpose. Like what's going to come out in the calculator? This is, once again, it's more for the GDC. More for the GDC. So for example, because the GDC can't give you like infinite examples, they have to give you one example. So what we see here is that the answer it gives you is going to be in the first or the fourth quadrants. 90 to negative 90, and that makes sense because sine is positive up here and sine is negative down here. So we'll see in the calculator, if I ask you the sine of radical 2 over 2, it's going to give you pi over 4. It's not going to give me the second quadrant angle. That you have to figure out on your own. If I ask for the sine of the inverse sine of like negative a half, you say, we know it's not in the first quadrant. We know it's a reference angle of 30, but we don't know, so what the calculator is, because we've restricted the domain from negative pi over 2 to pi over 2, it's going to say, you know what, negative 30. But once again, it's just so we know the reference and we know what's going on. Once again, we need an answer. It's either positive or negative. The next thing we're interested in, where's my notebook? The next one we're interested in are cosine. And it's the same idea, the same restrictions. Sorry, let me use my pen. Where's my eraser? So our cosine is the same idea. let's take a look at y equals cosine of negative 1x. And so we take a look at let's take a look at cosine again. Clearly we can see, how are we doing for time? Perfect. Clearly we can see that this is not, it is a function, it's just not one-to-one. It's going to fail the horizontal line test. So what we're going to do is we're going to restrict the domain a little bit. We're going to restrict the domain from 0 to pi. From 0 to pi. So if we restricted the domain, from 0 to pi, look at the new notation I'm using. Then the range is still negative 1 to 1. But what we've done is, sorry for using red, what we've done is that the inverse cosine, the domain is now negative 1 to 1, and the range, or the output, is now from 0 to pi. And so why is it different? Well, why can't we use it? Well, first of all, what's great about 0 to pi is that in this area, cosine is positive here, but negative here. So we definitely know. So when we look at the output in the calculator, we definitely know, what angle we're looking at. And then we can do repetitions of 2 pi. That's the idea. And so that's the idea. And then let's take a look at the graph and let's see what's going on here. So what's a couple of points? What's this point? This is 0, 1. Sorry, let me do this in red, and then I'll do the inverse in blue. This point is 0, 1. This point is pi over 2, 0. And this point down here is negative 1 pi. No, I'm sorry. It's pi negative 1. So in blue, if we take the inverse, what's the inverse? Well, it's 1, 0. The inverse, it's 1, 0. This becomes 0 pi over 2. And then what's this? This is negative 1 pi. This is like negative 1 pi. So I can plot that up here. And it's not the best graph, but you kind of see it's the reflection. So what is that? I guess it would be up here. Let me do the best I can. Let's see. Come down. Yeah. And that's the inverse function. It's not the best graph. So you can look at it in the if you go to Desmos and you put the y equals r cosine, you're going to get this restricted domain. It's going to look exactly like this. And then you can do some problems over there like that. And then it'll give you the 2 results. The results will be from the GDC will be in the different quadrants. But last thing we want to talk about. So what is the cosine? What is the inverse cosine of radical 3 over 2? And we know that is 1/2. No, it's not 1/2. Radical 3 over 2, so we know it's 30 or pi over 6. And then the idea is, what is the inverse cosine of like negative radical 2 over 2? Well, we know that this is the output for this is either in the first or second quadrant. What angle gives us an output of a negative number? We know that it's in the second quadrant. It could be in the second or the third, but the inverse cosine, the domain is from. The range is from, the range is from 0 to pi, so we know it's the second quadrant angle. We know that this is 45, so it's 135, so it's 3 pi over 4. The last thing we want to look at is tangents. Tangents is just very straightforward. The tangent inverse, I'm just going to do it on the board. We know that we're going to restrict it. I'm just going to tell you, we're restricting tangent from negative pi over 2 to pi over 2. So it kind of looks like this. By restricting everything else, we have a one-to-one function. It kind of looks like y equals x to the third. It's not. It's close. You can test that out. And therefore, we can look at the. I'm sorry. So this is tangent, and therefore the inverse is just make these. So if the domain is negative pi over 2 to pi over 2, then the range is negative, pi over 2 to negative pi over 2. And we know it looks something like this. Let's take a look at this. Okay, so the domain is from negative pi over 2 to pi over 2. Therefore, the range is from negative pi over 2 to pi over 2. And if the range is the entire reals, the domain of the inverse is all the reals. Sorry about that. I'll delete my round layout. So just little things. The idea is inverse function. We know that, f of the inverse function of anything is equal to x. So one example is the sine of the inverse sine of x is equal to x, and we can use cosine. The cosine of the inverse sine is x, and the tangent of the inverse tangent equals x. In the book they talk about you have to be careful if you switch these around. Remember, only the domains of the inverse functions are restricted. So I can put anything into sine, cosine, and tangent, but I can't put anything into inverse sine, inverse cosine, inverse tangent. And let's just finish up this unit by doing some the subunit by doing some problems. So let's see. How about this one? Evaluate example 1. What is the arc sine of radical 2 over 2 plus the arc cosine of 1/2. Pause and then you can come back. So what do you think? Well, I know that this is 45 because I've memorized our pi over 4. So, sorry. So I know that this is pi over 4, and then the cosine 1/2. So that I know is 60, or pi over 3. And so what is it? It's 7 pi over 12. And then what's going on in the next problem, example 2, we have the arc tangent of -1 plus the arc cosine of negative radical 3 over 2. So the arc tangent of -1, once again with tangent, we described it, is from negative, it's either in the first quadrant or the fourth quadrant. Now I know the tangent of 45 is 1, but I'm not doing 45, I'm doing negative pi over 4, and the arc cosine of radical 3 over 2, well I know that's 30. I know that the cosine of 30 goes to radical 3 over 2, but I'm not in the first quadrant. This is negative, so I'm in the second quadrant, and so it's the reference angle is 150, or 5/30 is 5 pi over 6. And what do we have here? It's 20 minus 6, so it's 14 pi over 24, which equals 7 pi over 12. And that's the end of try the problems at the end of the unit, and that's the end of the unit, and then we'll have a test next Thursday. Good luck.